Hello and welcome to all students. In this lecture, we are going to see about mathematical and statistical techniques second. So this is a class of F5 become students semester second, and this is mathematical and statistical techniques second paper second. And today we are going to see about unit number 1 function. It is actually functions. Okay, so first of all we see some introductory part, and then we see some basic concepts. Functions are of different type, and we will see in this chapter the all types of functions. Okay, so function is nothing but a relation from one set to other set. In the basic concepts, so first basic concept is about constant, and constant is the quantities which do not change are called constants. The second concept is a concept of variables. So first concept is about a constant. Constant means a quantity which do not change. Okay, it's called as a constant. And the second concept is a concept of variables. Variables, and the variable is exactly opposite to the constant. The quantities which change are called as variables. Okay, so we write here quantities which do not change. And we write here variable is a quantity which change, which are quantities which changes or which change, changing. Okay, quantities which change are called as variables. So this is the basic: do not change and changing. So these are so this is the basic difference between constants and variables. Okay, in mathematics the constants are denoted by numbers, whereas the variables are denoted by the symbols. So constants are denoted by numbers and variables are denoted by the symbols like x, y, z. So these are the notations for constants and variables, and the notation for constants are numbers. Sometimes constant is denoted by c. C is nothing but some number. C is some number like 1, 2, 3, like this. Okay, so this is about constant and variables. Okay, now we see some examples in the above case. The okay, we see some examples now. For a child, the age and the height are related. Okay, age and heights, these two variables. So age and heights are, these two are the variables. So for a child, the age and the height are related. In fact, the height depends on the age. Okay, we know that. The height of children depends on the age. Height of the children depends on age of children. Depends on age. So if I write a variable y for height and variable x for age. So age does not depend on anything. Therefore, we write here y is function of x, means y depends on x. Okay, so this is the notation for function. So as x changes, y will be changes. Okay, means as age goes on changing, height also goes on changing. Okay, so here we say that age means x is an independent variable. So this x is called as independent variable. Independent variable. And this y means height is called as dependent. It's called as a dependent variable. Okay, so because y depends on the age, height depends on age. Okay, and in this way we write this function y equal to f of x. The meaning of this thing is y is equal to function of x, means y depends on, f is called as depends on x. Okay, y depends on x, so x is independent variable and y is dependent variable. Okay, so in this unit we will be studying some standard functions in mathematics as well as in economics, which will be very useful in business and commerce. Okay, so let us go to the next concept of functions now. Concept of functions. Okay, for two variables x and y, if we have y is equal to f of x, means y depends on x, is a function, then we write the following things. Then what we have, first thing we can say is the set of all values of x for which this function is defined is called domain D of the function f. So first is the definition of domain. Domain is denoted by D, and it is nothing but it is the set of all the values of x such that y is equal to f of x is defined. Okay, so this is called as a domain. And second, we write here x is independent variable. So what is x? Independent variable. Okay, now first, second, and now go to the third. Y is called as a dependent variable. As we know, y is dependent variable. Fourth is the every value of x from the domain D of function f, there is a unique value of y such that y is equal to f of x. So for every value of x, there is a unique y. Okay, next I want to write fifth is the set of all the corresponding values of y for x in the domain D is called the range R. Range of the function f is nothing but it is the set of all the values of y such that y is equal to f of x and x is in the domain D, and this set is called a set of all values of y. That set y is called as range of function f. Okay, so all values of y is called as a range. The function f is said to be defined from D to R. It is expressed symbolically as, now here we have two sets. Okay, so first set is the set of domain and second set is the set of range. So here we write function f is defined from the domain D to the range R. Okay, domain D to the range R. So this is the notation to denote the function f. F is the function from set D to set R. Okay, now we will be studying only those functions where D and R are subsets of real numbers. Means we are seeing only real valued functions. Here we are studying only real valued functions. Okay, function whose domain is a real set of real numbers, subset of real numbers, and set of range is also a subset of real numbers. Okay, so real number means vastav sankhya. Okay, now we see some standard mathematical functions. So why we are studying function? We are studying function because they are very much useful in economics and business and commerce. That's why it is necessary to study functions. Okay, so now let us go to some standard mathematical functions. Okay, right here standard mathematical functions. So which are the standard mathematical function? We make a list here and we study one by one now. Okay, so first standard mathematical function is type of function is algebraic functions. Okay, so we write here this one, algebraic functions. Algebraic functions. So this is the one group of functions, algebraic functions, and in this group there are many functions. First is constant function, is one of the algebraic function. Constant function, one of the algebraic function is a constant function. The very first and simplest mathematical function is the constant function, and it is given by, that function is defined like this: f of x is equal to c. Okay, and it is okay, f of x is equal to c where c is constant. So see here, this function is depends on x, so if we change value of x we get a c constant. C is constant, we get c which is constant. Okay, so its graph is represented in the following figure now. So I would like to draw a graph for this constant function. Okay, so how to draw graph we will see now. 1 minute. So I would like to draw a graph for this function, but how can I draw now? Okay, go to here. Okay, and suppose this is our x-axis and y-axis coordinate system. Okay, x and y axis coordinate system. Okay, now write here as well x axis, y axis, both are perpendicular. Okay, now we draw the graph of constant function f of x is equal to c. F of x means it is the value of y and value of y equal to c. Okay, so we, for any value of x, the value of y is c. So we draw, suppose 1 minute, suppose here it is c on the, suppose here it is c on the y axis. Then the graph of, and suppose there is a extension of this x axis on the right hand side also, the graph of that function will be a straight line passing through the point C and which is parallel to x axis. Okay, and we write the name of this function as y equal to c, or we can write the name of this graph like this, f of x is equal to c. So this is the graph of constant function. Okay, so let us go to the second algebraic function, and that second algebraic function is a linear function. Okay, linear function. A linear function is of the type, let us write the type of that linear function. F of x is equal to a into x plus b. Okay, where a and b are constants. A, b are constants. Okay, x is a variable. Okay, the values of a and b is fixed, the value of x is not fixed. Okay, so writing the graph of the function is a straight line. That's why this function is called as a linear function. Okay, so let us try to draw the graph of this function. So once again we choose the xy coordinate system like this. Suppose this is our x and y coordinate system. Okay, so here it is x axis, y axis, both are perpendicular to each other. This is origin. Okay, and okay, now so let us try to draw the graph of this. Is always a straight line, any straight line like this, which crosses to x-axis, y-axis, and we write the equation of that graph, means the equation of that line, y is equal to ax plus b. Okay, so this is our linear function. The graph is always a straight line crossing to x-axis, y-axis, or may not cross. Sometimes it never cross to the x and y-axis. Okay, so remember the graph is a straight line. Okay, the graph of a function represents a straight line, and hence such functions are called linear functions. Okay, note that the degree of x in the expression is 1. So degree of x means power of x is equal to 1. That's why this function is called as a linear function. Graph is straight line. Okay, now let us go to the third type of algebraic function, And the third type is, we write here, third type of function is function with power of x. Function with power of x means a function look like this: f of x equal to x raised to n, where what is n? N is any real number, belong to the set of real numbers, vastav sankhya. Okay, the extension of these type of functions is, so let us write the extension of this function. General function, general form of such a type of function is like this: a into x raised to the power n plus b into x raised to the power n minus 1 plus c into x to the power n minus 2 plus dot dot dot. Okay, so this is the extension or general form of such type of function. A, B, C are constants. Okay. Okay. When all the powers of x are non-negative, it is called as a polynomial function. Okay, so these are the powers of x, and if they are non-negative, then this function is called as polynomial function. So let us we write here polynomial function. Just note it, polynomial function when all powers are non-negative. Okay, so let us write one example of a polynomial function: 6x cube plus 5x square plus 10 into x plus 6. Okay, so this is one example of polynomial function. You can write many examples. Okay, note that the constant functions and linear functions are the special cases of polynomial functions. Okay, whenever the power of x is negative, say x raised to the power minus 3 like this, then it will be represented by 1 upon x cube and so on. Okay. Secondly, suppose we have a function like this with power negative. F of x is equal to 6 into x raised to the power minus 3. Then this function can be represented like this. Okay, 6, or we can write 6 upon x cube. Okay, so for the negative power we write like this. Okay, no problem. So there are many types of functions. Next type of function is exponential function. Next set of type of functions is exponential function. Okay, exponential function. These are of the type of f of x is equal to e raised to the power x, and f of x is equal to a raised to the power x, where a is strictly greater than 0. So exponential function we can write like this or like this. Two forms of exponential functions. So let us go to the graph of these two functions. The graph is very simple. So let us try to draw first graph. Let us try to draw first graph of exponential function. Okay, this is x-axis. Suppose now this is y-axis. Okay, both are x-axis, y-axis, both are perpendicular to each other. This is origin. Now I want to draw the graph of exponential function y equal to e raised to the power x, and the graph is like this. The graph is like this. So we try to draw the graph now. So graph of this exponential function is like this. So I try to draw the graph of exponential function. So this is y equal to e raised to the power x, and it crosses to the point at where 0. When the value of x is 0, the value of function y is 1. Okay, it crosses at this point, and when the value of x is 1, the corresponding value of y is e. Okay, so now let us draw the next graph of function a raised to the power x. So again we draw x-axis, then we draw a y-axis. Okay, and this is our x-axis, y-axis, both are perpendicular to each other. Cross section is in, cross point is origin, and we draw the graph of a raised to the power x like this. The graph is same. Okay, this is again a graph of the function y equal to a raised to the power x. The graph of e raised to the power x and a raised to the power x look like same. Okay, so here it is function y is equal to a raised to the power x, where a is greater than 0. Okay, and the next last type of function is logarithmic function. So this is the last type of function. We write this is third, 1 2 3, and this is called as logarithmic function. Logarithmic function, and it is given by the notation or formula y equal to log of x to the base e, where x is strictly greater than 0. It is defined only for positive x. Okay, we have already solved numerical examples on functions and their values in school. However, here are few examples to review your concept. And the graph of this logarithmic function is like this. So let us try to draw the graph of logarithmic function. Okay, so suppose this is now x-axis, y-axis, origin. Okay, and graph of logarithmic function is like this. See here. So now let us go from top to bottom. Okay, see here, I would like to draw the graph of logarithmic function like this. See here. Okay, okay, so this is the graph of y is equal to log of x to the base e. Okay, where this cross point is 1, so log of 1 to the base e is 0. Okay, so these are the types of, these are the some types of functions. Okay, and now today we stop here. This is the end of our lecture. Okay, thank you. Thank you for paying attention. In the next lecture we will see some standard functions from economics. Okay, so let us stop here.